Hello, this is Brian Olchogi, and in celebration of reaching 5,000 YouTube subscribers, I thought I would make this plaque and show you how I'd set up a job like this in RhinoCam, and also machine it and then eventually cast it in aluminum. So when I start out with a project like this, generally I will actually model the thing that I want to make, even though you could probably do this with a V-groove bit without any modeling required and just do it from a 2D file. But I kind of like to know exactly how everything's going to land and what the transitions are going to look like. And the other benefit of doing it this way is that you can actually just use the engrave operation in RhinoCam in order to just sort of pass a bit along all of these creases. And I'll show you what I'm talking about. So another thing that I generally do on a multiple operation file such as this is that I'll actually sort of splay out all of the operations. So especially the 2D operations, it doesn't matter if it's here at your origin until you're ready to post it. And so this sort of helps me keep organized, and I can always just stack them back together like a deck of cards to see the final result. So what I'm going to do first on this model is these letters are curved, just so that in the final version it's going to sort of catch light or reflections, and so I want that to be a smooth bow across this face, and that I'm going to do with parallel finishing. So if I turn on the tool path so we can see what that looks like. So this is a simple ball end mill that's going to go along this surface to make a super smooth surface first, and then I'll do 2.5 axis pocketing, and that's just going to sort of get rid of a lot of the material in here, and another pocketing just to get rid of the material that exists down in here. And then here I'm going to do an engrave, and so what this will do is add a pattern sort of in the background and on the letters with the V-groove bit. And I could have just used the parallel finishing command in RhinoCam, but I instead actually just drew these, connected the ends into one long string, and that way I can sort of control where everything lands. Then there's this, which is sort of a cleanup pass around all of the edges, and you can see that those are in 3D space as well, so I'm going to also be using engrave for that. And that will just pass the tip of the V-groove along those lines. And then the final is actually just using the V-carving operation in RhinoCam to cut out these letters. And then the final would be to actually cut the thing out. And for most of these, I'll be using the Amana in-groove system that allows you to sort of switch out various tips, and your zero is maintained. But for this one, I'll have to actually use a 1/4 inch end mill, just because the depth of cut on the flat Amana end mill is only like a 1/16 of an inch or maybe an 1/8 of an inch. So I'll show you what this all looks like all stacked together. I'm not actually going to use the 3D model for anything, so I'm going to move that out of our way and restack these over the origin. So these are just grouped for easy selection and deselection. Okay, so now those are all in place, but since I moved them, RhinoCam wants me to regenerate them, otherwise it'll all happen out here. So I'll just select Setup and Regenerate. Okay, so now that's all regenerated to be right here at the origin, and I'm going to go ahead and go to Simulate, and I'll turn off the tool paths and we can see what's going to happen. there's the plaque all cut out. Here's the texture that's just generated by the step over, and here you can see where the cleanup pass goes around the edges. So I'm going to go ahead and post this, and then I'll see you at the machine. This is the Amana in-groove tool holder, the 1/4-inch ball insert, the 1/4-inch flat insert, the 60-degree V insert, and the 1/4-inch 2-flute end mill. Here you can see the different profiles and how I will not need to re-zero between the ball and the flat insert tool changes. The insert is held in place by this socket head screw. The various inserts cost about $20 a piece. If you buy this system, I would recommend only getting the knife holder and then buying the inserts individually that you'll actually use. I made a witness mark at the origin because I will need to re-zero for the V-knife insert. Now I will coat the part with epoxy. I usually use polyurethane for this, but I wanted to be able to sand this fairly quickly and not have to wait a couple days. When you remove one face in the material, the part will start to bow towards the cut side. I'm adding supports to counter this while the epoxy is applied. This epoxy is mixed at a 5:1 ratio by weight or volume. I have heated the MDF part in an oven to a little over 100 degrees. This will help the epoxy soak into the surface without altering the characteristics of the epoxy. I use 2 coats of epoxy, as I don't mind if some of the detail in the background texture is subdued, as this will make it more likely to easily release from the sand mold. Now I can sand off all the MDF fuzzies and make a smooth surface. In the next half of this series, I'll use this pattern to cast aluminum and paint and sand the final plaque.